Now see, in this question we have to find area enclosed by this curve. Now see, it's not a very simple curve, so let's see how we handle this curve to find area bounded by this curve. Area bounded by, you can say, area enclosed by a loop that is formed in the graph of this. Now if you just look at this, we can simplify it like this. So we will find area bounded by this curve, and then we replace y by y minus sine inverse x. You know this transformation, that if we replace y by y minus a positive, we shift graph. In y equals to fx, we replace y by y minus a. So we shift this graph a units above. For example, if we have, say, this mod curve y equal to mod x, and we replace y by y minus 1. So the graph of y minus 1 equal to mod x is shifting of this 1 unit up, and you can see shifting of 1 unit up means every point on this graph will go up by 1 unit. Each and every point on this will move up by 1 unit, means y coordinate of every point lying on this graph will go up by 1 unit, right? So that's what we are planning to do here. We'll draw a graph of this, and then we shift this graph by sine inverse x units above. I'll show you how we do it. Now this is a circle. This curve is a circle whose center is half, 0 and radius is half, and this curve is passing through origin because constant term is 0. So we draw this circle. You can see here we draw this circles whose passing through origin, center is half, 0 and radius is also half. Now if you look at graph of sine inverse x between 0 and 1, this is how sine inverse x behaves between 0 and 1. Now you can see all these points between 0 and 1. For example, see this point. We have to move this whole graph up by sine inverse x unit, but sine inverse x is not a constant unit. So basically at every value of x, the unit by which we'll shift the graph up would be different. For example, at x equal to 0, if we replace x equal to 0, sine inverse x is 0. So this point is not going to be shifted, or this point has to be shifted by 0 unit, so it will remain here only. If you look at this one point, when we replace 1 here, sine inverse 1 is pi by 2. So this point will be shifted pi by 2 units up. Pi by 2 means 1.57. So this point will come here. So you can see this circle will be plotted between these 2 points, like this, between these 2 points, right? It will change the shape also. So we have to draw the rough idea, because we just find the area bounded. So all these points on the circle, for example this particular value of x, this particular value of x, we have to move this point up based on the value of sine inverse x at this value of x. Both of these points will go up by units, which would be, if this is point A, we have to move these 2 points up by sine inverse A. If you do this, the new rough idea is this is, and we don't need to be precise here, we have to just find area bounded. So rough idea is that this circle, after we apply this transformation, sine inverse x will become like this, right? And this is the area we're supposed to find. Now you can see, if I take square root of this, we have y minus sine inverse x equals to plus minus square root of x minus x square. So there are 2 curves, y equal to sine inverse x plus root of x plus x minus x square. Say I say curve 1, and y equal to sine inverse x minus root of x minus x square, second curve. And obviously you can see this is greater than this, because we are adding a positive value to this and we are subtracting a positive value, so this is more than this. So if I say this is y1 curve and this is y2 curve, you can see this is y1 curve and this is y2 curve, and we have to find area bounded between y1 and y2, right? So shaded area can be written as area from 0 to 1 upper curve minus lower curve, that is y1 minus y2 dx. And from this you can subtract y1 y2 and see y1 minus y2 is, the difference is 2 root of x minus x square dx. Now you can apply integration formula. You can make perfect square here, perfect square in this part, and apply this formula, root of a square minus x square, and calculate the answer.